We are looking at conic sections. We just looked at parabolas, and now we're going to look at the conic section, which is an ellipse. So let's read through the definition, and then let me give you some terminology and formulas. And so the following states that an ellipse is a collection of all points in the plane whose sum of the sum of whose distances from two fixed points called foci is a constant. Okay, so we had these 2 points. For a parabola, we had one focus. For an ellipse, we have, and it's plural, 2 foci. And so these 2 foci, these are always on what is called the major axis. This major axis right here, this is, has a length of 2a. Our minor axis is always the smaller axis. Both of these axes go through our center. So the major axis, let me write that down. Has length 2a. I'll show you about a in a minute. And the minor axis has a length of 2b. Think of it to draw this ellipse. You would put 2 tacks on your foci with a string. That string, that distance of that string is always the same, right? And so if you put those 2 tacks on the ends of your string and you pull it tight with your pencil and start taking it and going around so that it's always taut, it would make the shape of the ellipse. And you can kind of see that diagram right in here. Okay. So the sum of these 2 distances, wherever we may lie, is always going to be this constant c. It's always the same length. Okay, so let me give you some equations, and it really depends on which way our parabola is facing. So we're going to look at it where this major axis, the longer axis, is either parallel with the x-axis or parallel with a y-axis. So it's either elongated towards the x-axis or elongated towards the y-axis. And depending on which way, depends on which equation that we use. Okay, so there's 2 of them right here. Depending on, it's parallel to the x-axis, then the value of a for an ellipse, and don't get hyperbola, what we'll talk about later, has a value a2, and don't get confused with this because they're different for ellipse and hyperbola. But anyways, for an ellipse, the value of a is always bigger than b. And so notice that in here we have this x minus h quantity squared plus y minus k quantity squared is equal to 1, actually. And this x minus h quantity squared is over a squared, and this y minus k quantity squared is over b squared. So really, technically what I do is I look at my denominators, which one is the bigger number, depending on if it's underneath the x values or the y values, depends on if it's elongated with the x-axis or with the y-axis. And so notice that here, almost exactly the same formula, except that the a is underneath the y values instead of the x value. Okay, so we have this in here. So a is bigger underneath the x, is going to be elongated this way. Your center is always in the middle of the ellipse. So our center is at HK. And so these vertices, to get to these vertices, so it's major axis going through my center. These are the vertices of the major axis, which are on the ellipse. So vertices of the major axis well, remember that length I just told you was 2a. So if that length is 2a, we're going to go over a length of a to the right, and we're going to subtract a to get to that point on the left. Well, if I add or subtract a, and then I'm moving it along the parallel with the x-axis, that's going to affect my x value. So to get my vertices, I'm either going to add or subtract a from the h value of my center. So my vertices I could get would be h minus a, y would stay the same, k, and h plus a, comma k. The foci are always on the major axis. The foci, the length between the center and the foci is c. So for our foci, again, from our center, adding or subtracting c from our x value with a major axis parallel to the x-axis would give us our points. So we would have h minus c, comma k, and h plus c, comma k. The minor axis goes through the center. And these are our vertices on the minor axis. So vertices on the minor axis. Well, this length is 2b. So we would go up b from our center, and we would go down b from our center. And so that's affecting my y value of my point. My x value is going to stay the same. So my vertices are going to be h, comma, k plus b, and h, comma, k minus b. So that's if it's elongated with the x-axis. Almost identical, but now let's look at it if it's elongated. The major axis is parallel to the y-axis. So if we're looking at that formula, the only difference is that the a value, the bigger number, that a squared is underneath the y terms instead of the x. So this would be x minus h quantity squared all over b squared plus y minus k quantity squared all over a squared. And this is equal to 1. So same idea, center is still hk, but this is elongated this way. And so if this is hk here, and we wanted to get the vertices of the major axis, that means we are going to go up a from the center, and we're going to go down a from the center. And so the vertices on the major axis, if it's parallel to the y-axis, our x value is staying the same as the center. So it's going to be h, comma, we're going to add a to k, so comma k plus a, and then X value is the same as the center H, and then we're going to subtract A from the Y value. So K minus A at the center. The foci. Foci that has a length of C. So we're going to go up and down a length of C. So our foci, the H value stays the same, and we're going to do K plus C and H comma K minus C. And the vertices on the minor axis, that length is always 2B. So we're going to go over B to the left and to the right. So vertices on the minor axis is H minus B comma K and H plus B comma K. For ellipses, we can figure out what C is. And C squared is always equal to A squared minus B squared. Okay, so looking at an equation, and even if it's not in this form where I can see where the center is and get information, I can tell if it's going to be a parabola, a circle, or an ellipse. Parabola is only either going to have an x squared or a y squared, but not both. Ellipses have to have both an x squared and a y squared. Same thing with circles. Only difference is that with circles, that coefficient in front of the x squared and the y squared are the same if it is a circle. If it is an ellipse, those coefficients in front of the x squared and the y squared are not the same, but they're going to be the same sign. They're either both going to be positive in front, that coefficient, or both negative. Ellipses, they're opposite signs. Not ellipses, hyperbolas, but we'll talk about that probably next week. Okay, so those were some major, there was some terminology in here that you needed to be familiar with: the major axis, the minor axis, where is it parallel to, and then the foci, vertices on the major, minor axis, and the center. So let's go through and look at some examples. So the example in front of us says x plus 4 quantity squared, that's all over 9, and then plus y plus 2 quantity squared, that is all over 4. This is equal to 1, and it wants us to analyze each equation, find the center, foci, vertices of the ellipse, and graph the equation. Okay, so it's already in this form that I can tell what the center is, and I can tell which way it's elongated. So looking at the larger number in the denominator, I see that's 9. The 9 is underneath the x values, so that tells me that it's going to be elongated with the x-axis. Pretend that's a... Okay, and so here we know what our center is because it's in that form. So HK, my H value opposite with my x is a -4, comma, my K value opposite what's inside, so -2. So I know I have a center at -4, -2. And then we can figure out what our vertices are. So A squared is 9. When we look at A, we're not looking at plus or minus because we're thinking of distance. And so when we take the square root, we're just thinking of the positive. So A is 3. So that tells me A is 3. I need to go to the right 3 units, and I need to go to the left 3 units from my center. So I can, by knowing where my center is, which is at -4, -2, if I go to the right 3, that is going to give me a point at -1, -2. So vertices. So for our major axis, we have that point -1, -2. And if we go to the left, 3 from -4, that's going to hit me at a y value of -7. So and -7, -2. So for the minor axis, we need to look at our b value. Well, looking at it, b is a smaller number, b squared. B squared is 4. So I know that b is equal to 2. So I'm going to go up and down 2 from my center, which affects the y value of my point. So up from the center. So my center, my x value is -4. Going up 2 from -2 gets me to 0. And then it's -4 going down 2 from my center. That y value would be -4. And so we have what our graph looks like. And we can do that graph without, it's not kind of to scale, but there's my ellipse. What was I going to say? Noticing where the foci is not going to really help me with this graph, but it does want us to find the foci also. So let's find that. Foci, we need to figure out what c is. So c squared, recall, was a squared minus b squared. So c squared is equal to 9 minus 4. So c is equal to plus or not, it's positive, always positive, it's a length. So if I take the square root of both sides, that would be the square root of 5. So I'm going to add and subtract root 5 from my center. I don't like how my ellipse looks. That looks a little better. Okay. Anyway, so let's add and subtract, and I'm just going to put it in the exact form. So let's just leave it like that. So adding and subtracting root 5 from my x value. So my x value of my center, that was -4. So I have -4 minus root 5, -2, and -4 plus root 5, comma, -2. And we can get those approximate so that we can graph them. So let's look at it. So -4 plus root 5. That gives you back about -1.8. About here. And then -4 minus root 5. That gives us about -6.2. So about right here. Those would be the foci. But again, that doesn't really help me graph it. So that was an example. It was already given to us in standard form. So let's look at another one. So let's look at one that's not in standard form and we have to put it in standard form. And so if we had, let's say, x squared plus 9y squared plus 6x minus 18y plus 9 equals 0. Okay, so we want to put this in standard form. That way we can see what the center is. We can see is the major axis parallel with the x-axis or the y-axis. We're going to need to complete the square both on our x and our y terms. So let's rewrite this, grouping our x terms together, our y terms together, and that constant on the other side, just like when we were dealing with circles. So x squared plus 6x. I know I'm going to need to add something in here to make this a perfect square. So I'm just going to leave the space there. And then we have our y terms. So we have plus 9y squared minus 18y. I'm not going to add anything right. Well, I'm going to need to add something here, but I can't complete the square on these 9 y values yet because of that 9 in front of the y squared. And so let's subtract 9 on both sides, negative 9 plus whatever I add over here. Okay, so we can complete the square on the x terms because that coefficient in front of the x squared is 1. So half of 6 is 3. So that's the same number we add to get 6. We need to figure out if we multiply 3 by itself, 3 times 3, that's 9. So that adding 9 would make this a perfect square here. So we can rewrite that. That's x plus 3 quantity squared plus, so we need to factor out this 9 that is with the y terms. And so if we pull out a 9 from those y terms, we're left with y squared minus 2y. This is where we're going to think of it as, I don't know if you want to do it this way. Let's just think of it as we're going to add something here in here to make this a perfect square. Let's do it this way. Minus 9 plus 9. Let's just add these right now. Negative 9 plus 9. That is equal to 0. The thing that we're adding on the left-hand side has to be multiplied by 9 when we add it on the right-hand side. So it's 9 times whatever we added here, because this 9 has to be distributed to move it outside the parentheses. Okay, so let's figure out what we're adding inside the parentheses. So having negative 2, which is negative 1. So negative 1 plus negative 1 is negative 2. The thing that we are adding, that constant, is negative 1 times negative 1. So that number is 1 here. So let's rewrite that. That's now a perfect square. So this is x plus 3 quantity squared plus 9 all times y minus 1 quantity squared equals 9. Every single standard form for that ellipse was always equal to 1. And so that coefficient, what we have it, is equal to 9. And so we can make that equal to 1 by dividing every single grouping or term by this 9 on both sides of the equation. So doing that, this gives me x plus 3 quantity squared all over 9 plus, notice the 9s cancel right here. So this gives me y minus 1 quantity squared, I'm going to just put it over 1, equals 1. So now it's in that form that I can tell that the major axis is parallel with the x-axis. So it's elongated this way. I can tell what my center is, HK, so opposite signs. So H is negative 3. My K value is 1. I can figure out what A and B are. I know that A squared equals 9, the bigger number. So A is equal to 3. It's elongated with the x-axis. So I'm going to add and subtract 3 from my x value of my center to get the vertices of the major axis. So adding and subtracting 3 from negative 3. So negative 3 minus 3, that's going to give me negative 6. 1 is one of the points. And negative 3 plus 3, that gives me 0. 1 is another point on the major axis on the ellipse. And so now let's look at vertices of the minor axis. Well, my b value, b squared is 1. It's a length, so it's always positive. Taking the square root of both sides, b is 1. And so we're going to add and subtract 1 to my y value of my center. So I have -3. Adding 1 to 1, I get 2. And -3 subtracting 1 from 1, I get 0. So we can start graphing what we have. So we have a point at -3, 1. So we have our center. Our vertices on our major axis, we have -6, 1, and 0, 1. Vertices on our minor axis, we have -3, 2, and -3, 0. So looking at our ellipse, we have something that looks like this. And if I wanted us to find the foci, we can do that. We need to figure out what C is. And we know that C squared equals A squared minus B squared. So C squared equals A, which is 9, minus B, which is 1. So C squared equals 8. C is equal to the square root of 8, or 2 root 2. Which is approximately 2.83. Okay. So we're just going to add and subtract that from our center and the x value of our center to make it on the foci need to be on the major axis. And so our foci, the x value is -3 of our center, so -3 minus 2 root 2, comma 1, and -3 plus root 2, -3 plus 2 root 2, comma 1. Okay, so you should be able to put the equation in that standard form of an ellipse if it's not already done so that you can figure out what the shape looks like. It's a major axis parallel to the x-axis or y-axis, and then be able to find your major and vertices on the major axis and vertices on the minor axis. So if you're given information about the ellipse and not the equation, and asked to find the equation, do the same thing that we were doing with the parabola. Start plotting your points, and then you should be able to tell information about that ellipse. Usually you can tell which formula you're going to need to use. So for example, if you were given that the vertices were 4,3, 0.43 and 4,9, and you were given that the focus was 4,8, or one of the foci is at 4,8. Okay, so plotting what I have 4,3 and 4,9. So I have a point here, and I have a point at 4,9. and here. My focus is always on, or foci for ellipse is always on the major axis. And so I have a focus at 4, 8. So right there, that tells me that my ellipse is elongated a parallel with the y-axis, that major axis. It's elongated this way. And so I know which type of equation I need to use. X minus h quantity squared all over b squared plus y minus k quantity squared all over a squared is equal to 1. We can figure out what a is because we know that the length of this major axis here is 2a. So 9 minus 3 is 6. So half of 6 is 3. So I know my a value is equal to 3. We can figure out what the center is. Center is always a halfway point between your two vertices. And so we can find that midpoint. So that was summing our x values. So 4 plus 4 divide by 2. Summing our y values, so 3 plus 9 and dividing by 2. So 4 plus 4 is 8. 8 divided by 2 is 4, which makes sense. It should be on 4. And then 3 plus 9 is 6. I'm sorry, 12. 12 divided by 2 is 6. So our center is at 4, 6. So we know what h is. We know what k is. We know what A is. All we need to figure out is what B is. And so we have a little bit of information, more information to figure that out. We know the foci, that distance is C. So right here, this distance is C. And so going from the center, which we know is the y value of 6, up to a y value of 8 to get to that focus, this length C, I know now is 2. So recall that C squared equals A squared minus B squared. So we have enough information now to figure out what B is. And we can even just keep it as B squared because that's what we want to plug in as B squared. So C squared, 2 squared is 4, equals A squared. A we said was 3, so 3 squared is 9 minus B squared. Let's subtract 9 on both sides. So we get negative B squared equals negative 5, or B squared equals 5. We need to figure out what A squared is. A squared, 3 squared is 9. So now we have our equation. We have x minus h, but h is 4, quantity squared, all over A, actually it's elongated with the x-axis, I'm sorry, y-axis. So B is under here. So this would be a 5 underneath the x's, plus y minus k, so y minus 6 quantity squared, all over the larger number, a squared, which is 9, equals 1. Okay, so given information about the ellipse, you should be able to find the equation of the ellipse. It's helpful, again, to plot the information given, and that's going to clue you in which type of equation to use. Okay, so this is 11.3 in our textbook on ellipses and conic sections. So let me stop here for the day,